0.0076 millimeters. That's 10 times thinner than a strand of hair. It's so small, most people wouldn't even notice it. But in ICU bracing machine, that number becomes a critical line between life and death. Hello, I'm Gilbert. Today, I want to share a story about how this tiny number becomes a matter of life and death in ICU. One of the top medical device companies in North America hit that limit while working on next-gen ICU airflow system. And the issue that all comes down to one key part, the oil-free scroll disc. When these machines run under heavy loads, even a tiny air pocket inside the part can slow off oxygen levels. That's not just a small error. It can put a patient's life in danger. They first tried using regular high-pressure die casting, running samples of samples, but each time the part had too many pores inside. The seals wouldn't hold. The design kept falling. They didn't just need to tweak the process. They needed a full rebuild of how the part was made. The part had to be dense. It had to go through the heat treatment. After CNC machining, it had to keep it shaped. That's when they come to us. From day one, we knew this wasn't just about hitting a tight tolerance. This was a 4 challenges: materials design, process, and inspection all had to work together. To match that 0.0076 millimeter precision, we had to make sure the surface was free of pores. It had to be heat treated to a T6 level. It had to be easy to machine without losing accuracy. And after all that, it still had to fit together, perfectly sealed. That's what we mean when we say high-quality die casting. It's not just about looks, it's about reliable performance. In critical places like an ICU, every part must be made with one goal in mind: nothing can go wrong. The old way of doing high-pressure die casting wasn't enough anymore. That's why we used vacuum die casting, more temperature controls, and tight post-processing controls. That's how we fixed the problems of porosity, deformation, and stability right at the roots. So what exactly does it take to make true high-quality die casting? We stepped away from the limits of traditional die casting and focused on the 3 advanced casting methods. First, vacuum die casting. This was the main process we used for this project. The idea is simple. Before we inject the melted metal, we pour out all the air from the mold, the runner, and the chamber. That way, the whole injection happens in a vacuum. This helps cut down air pockets by a lot. In some cases, porosity is less than 1%. No bubbles, no leaks. It passed airtightness test with easy. It also works well with the surface treatment, anodizing, and welding. Plus, the parts get stronger and last longer. This process is great for high-strength parts like medical housing and structural components. Next is squeeze casting. Here we first fill the mold with metal. Then we keep adding pressure up to 100 megapascal and hold it until the metal is fully solid. The pressure makes the grain tighter and more even. What's the benefits? Very low porosity, which means it can handle heat treatments like T6. It works especially well with A356, You'll get tight tolerance, smooth surfaces, less extra material to machine off, and fewer parts go to waste. The parts last longer too and stay stable under stress. This is perfect for complex, high-load parts that need heat treatment, things like robot arms, car suspension, and linkages. The third is semi-solid die casting. This process keeps the metal in a kind of slurry state, not fully melted, not fully solid. It flows easily but doesn't slam into the mold the way hard liquid metal does. So it avoids turbulence and trapped gas. That gives it big advantages. You'll get smoother flow and more consistent fuels, especially in multi-cavity modes. There are fewer welded lines and serrated spots. The molds last longer. It's easy to machine later, costs less, and it's great for automation. Since the parts come out close to final shapes, they're less cutting and wasting. This process works well for light, compact, and detailed parts like robot shelves, small brackets, and other lightweight components. For this project, we went with vacuum die casting. It solved the customer's sealing problem, the oil-free scroll disc. We delivered past every test, even after more than 1,000 hours of high-load testing. The machines stayed airtight and stable. But we didn't just meet the precision goals. We gave the customer a full casting solutions, from idea to full-scale productions for high-performance medical parts. Behind all this is the full process ability we built up at Sunrise over the years. From design reviews to process planning, mold making, vacuum die casting, precision machining, surface treatment, and full inspection. We make sure every performance point is covered. That's the real secret behind making truly high-quality die casting parts. If you're looking for a partner who truly understands die casting and knows how to solve tough engineering problems, talk to us. Let's turn your complex designs into real high-performance casting solutions. Thank you for watching. See you next time.